So if, see, 1 power infinity is an indeterminate form because look at this limit y tends or n tends to infinity. I'll put this way, limit n tends to infinity and limit x tends to 1, x power n. Now this limit is actually not defined, doesn't exist. Why? Because when x is approaching 1 minus, when x approaches 1 minus, that means x is slightly less than 1, which means it is like 0.999 something. Any number which is slightly less than 1 and you raise to the power infinity, what happens? It will tend to 0. Because let's say 0.9. So 9 by 10 is 0.9. I raise it to power 2. 9 by 10 is 0.9. 0.9 power 2 is 0.81. Power 3. What is power 3? 0.9 power 3. Anybody? 0.729. So it is reducing, you see. And we can see, say 0.9 raised to the power, say 25. So you observe it is 0.0717 and 0.9 raised to the power 100. It is 2.65 into 10 to the power minus 5. So any number which is slightly less than 1, any number lying between 0 and 1, you raise it to an infinite power, it goes to 0. However, when x tends to 1 plus, then it is a number slightly greater than 1. Slightly greater than 1. And you raise that to higher power, very large power, it will go to infinity. Okay. So again, we'll check that. Say 1.1, 1.1 raised to the power 10. Okay, it is 1.1 raised to the power 10 is 2.59. All right, now 1.1 raised to the power 100. It has become 13,780. Now 1.1 raised to the power 10,000, 100,000, it will go on increasing. So when a number is just less than 1 raised to the power infinity, it will go to 0. When a number is slightly greater than 1 raised to the power infinity, it will go to infinity. So that is why this 1 power infinity form, we do not know whether it will go to some constant number or whether it will go to 0 or whether it will go to infinity. That is why this is an indeterminate form. Okay. So this is indeterminate form. One power infinity. So Having said this, so now look at this particular limit, the first one. Limit f of x as x tends to a is equal to limit g of x as x tends to a is equal to 0. So f and g are two functions, both of which are tending to 0 as x approaches a. Then what happens to this limit? Now this limit you carefully observe. Limit as x tends to a of 1 plus f of x whole to the power 1 upon g of x. Okay, so it is 1 plus 0 to the power 1 by 0. So 1 by 0, it goes to infinity. So it is 1 plus 0, that is 1, whole power 1 by 0, that is infinity. So it is 1 power infinity form. Now this is equal to e power limit x tends to a f of x upon g of x. That means e power limit x tends to a, the 0 part multiplied by its power, the infinity part, 0 into infinity. Okay, so how do we get this? So this is the result 1. How do we get this? I can just give the formula, but there will be sometimes miscellaneous limits for which we need to apply the same method. So I am showing this how to do it. So we have limit x tends to a 1 plus f of x sorry, 1 plus f of x to the power 1 by g of x. Now let us call this limit as some value, say m. Let m be a number which is equal to this limit. Now let us take logarithm on both sides, natural logarithm. Ln will be, now limit is just a x approaching a value, so you can take a logarithm inside. So we'll get logarithm of 1 plus f of x to the power 1 by g of x. Now this will be limit x tending to a log of a power m is m log a, so 1 by g of x into log of 1 plus f of x. Okay, now we know that f of x is tending to 0 and g of x is also tending to 0 as x tends to a. So what I'll do, I will multiply and divide by f of x. Okay, so when I multiply and divide by f of x, this will be the standard result. I can split this into 2. Limit x tending to a f of x upon g of x, and this is an independent limit 0 upon 0 form. Limit f of x or f of x tending to 0, because as x is tending to a, f of x will tend to 0. So 1 log of 1 plus 0 upon the same 0 form. Yesterday we did this. This second limit is equal to 1. Okay, this limit is equal to 1. So we are left with limit x tends to a f of x upon g of x. Both are going to 0. It is a 0 by 0 form into 1. So this is same as log m, but we want m, right? So m is, after you evaluate this limit, we get e power limit x tends to a f of x upon g of x. Okay, so that is how we get this result. You see here, limit x tends to a 1 plus f of x to the power 1 by g of x is equal to e power limit x tends to a f of x upon g of x. Okay. So that is what this limit is. Now, exactly the same is this one, the second one. This is just another form of the same limit as the first. Same procedure we need to do. What is this? Second result is if limit x tends to a f of x is equal to 1 and limit x tending to a g of x is going to infinity, then this is x tends to limit x tends to a f of x power g of x 1 to the power infinity. This is same as this one. This is same as, okay, the final result is this. I will write down again. This is same as e power limit x tends to a f of x minus 1 into g of x. How do we do that? How do we get? I will just show that. Result 2. So again, let m be equal to limit x tending to a f of x to the power g of x, where limit x tends to a f of x is equal to 1 and limit x tends to a g of x is equal to infinity. So it's 1 power infinity form. So what we do is take logarithm on both sides. So we get this as limit x tends to a. I'll directly write the step. Log of f of x power g of x is g of x into log f of x. Now, what I do is limit x tending to a. I will write this log of f of x, because it is tending to 1, I will write as 1 plus f of x minus 1. Now this becomes the form log of 1 plus 0, because f of x is tending to 1. So f of x minus 1 will tend to 0. So log of 1 plus f of x upon I will divide by the 0 part. F of x minus 1, f of x minus 1, and of course, okay, I'll write that side. Here we have g of x, and I'm multiplying and divide by f of x minus 1. So now I can split this into two parts. This is f of x minus 1 comes here into g of x. F of x minus 1 tends to 0, g of x tends to infinity. So that is basically 0 by 0 form, or you can say infinity by infinity form. Multiplied by, I will, so as x tends to a, f of x tends to 1. And which means f of x minus 1 tends to 0 log 1 plus f of x minus 1 by f of x minus 1. So this part, this limit is 1. All right, the standard log of 1 plus 0 upon 0 form, that is 1. So we have log m to the base e is limit x tends to a, f of x minus 1 into g of x. So what we get is m, that is m, which is nothing but limit x tends to a f of x to the power g of x. If it is 1 power infinity form, it is nothing but e power limit x tends to a f of x minus 1 0 into g of x infinity. E power limit x tends to a, this part, first factor should go to 0, the second factor should go to infinity. Okay, so that is the result. Okay, so let us do an example of this. Okay, I'll take one example. The first question example. Limit x tends to infinity x by 1 plus x whole to the power x. Now, which form is this in? Anybody? In which form is this in? Numerator is going to infinity, denominator is going to infinity, and this x. So what is this form in? Anyone? Please share.
Infinity by infinity form.
Pardon?
Infinity by infinity form.
Infinity by infinity. It will this inside
F
the
of
bracket.
x whole to the power of g of x form.
Yes. So this is, it is tending to 1. This inside function is going to 1. Why? Because let's say it is 10 lakhs. X is 10 lakhs. By 10 lakhs plus 1 is 10 lakhs and 1. That's it. This will tend to, this will be close to 1. Initially, it will be different. Say, if x is 1, it will be 1 by 1 plus 1, which will be equal to 0.5. But when x becomes larger, so see this. Okay. It is going to see 0.9999. So this is tending to 1. So this is 1 power infinity form. This is 1 power infinity form. F of x is going to infinity. Sorry, f of x is approaching 1, raised to the power g of x. G of x is going to infinity. Clear? So what is the result we will use? Just the result that is there above. 1 power infinity. F of x minus 1 whole power into g of x limit. So this is directly equal to, if you are in doubt, equate this to m and take logarithm on both sides. Otherwise, you straight away write this results. F of x minus 1 into g of x. So this is e power limit x tends to infinity. We'll get x minus 1 minus x by 1 plus x into x. So this is x, this is x. Okay. So this is equal to e power limit x tends to infinity minus x by 1 plus x, which is e power limit divide by, as x tends to infinity, so divide by x numerator and denominator, 1 by minus 1 by 1 plus, or 1 by x plus 1, or 1 plus 1 by x, same. So this is e power, apply the limit, minus 1 by 1 plus 0. We get e power minus 1, that is 1 by e.